see. Just waiting for the stream to begin. Waiting. Looks like we're good. All right. What's going on? One second. Streaming. Yeah, looks like I'm streaming. Okay. Shoot. My event isn't working. I guess so. Alright. Weird. This is really weird. Ah, man. I'm live streaming, but my event hasn't started. All right. Not gonna work. Bear with me for a second. Sorry, guys. That seems to be working. Okay. Dang. I passed out the wrong URL to Twitter to everybody, so I want to fix that real quick. Did not work. Heck. Technical difficulties all over the place. Seems to happen every time. Okay, now that I got this fixed, today I'll be showing you my progress on the Open Game Art Jam. If you don't know, Open Game Art, really cool website that allows you to use anything on their website and in your games with fairly free licensing. That's really cool. I just kind of learned about it recently. Through itch.io. They're running a game jam where you use art from this website. So I'm going to go with science as my theme. I'm using art from Iris, if that's how you say your name. I'm using the sci-fi platform tiles here. And then I'm also using art from Min. I'm using his scientist images here. Really cute little guy running around. So I'll show you where I'm at currently. I have the tiles working where I can lay out all the tiles. I have my player character colliding with the environment, being able to run around. And I just started work on a potion, which is really cool. I'll show you in a minute. Let's see where the game is currently. So currently, you're the scientist, and you really don't. You're gonna start off not knowing what to do, and it's a basic platformer. You're gonna go around. You're gonna pick up potions. They're gonna give you powers. Those powers would be like jump higher, run faster, invincibility, that kind of thing. Collect keys, open doors, solve little puzzles. That's my goal. So here's my little guy. He's idling, he's running, jumping. So I have the guy basically working. So now I'll show you the cool potion thing that I figured out. I've been learning Godot for a little bit. It's really powerful, and it's also different than anything else I've used. So it's taken me a while. But I have this potion here. It's an area 2D for colliding with the player. It's going to have a signal, and the player's going to pick it up, add it to his inventory. It has a collision shape, which I have hidden because it's basically just the shape of the bottle. And then it has the Sprite 2D. What's really cool is the Sprite 2D, if you can see over here, kind of small image. Let's see if I can open up that image in an editor real quick. Oh, let's see. I'll open it with Visual Studio Code. Oh, there's no zoom. Okay, that didn't work too good. Let's see. Okay, so basically there's an empty bottle, and then there's bottles filled with potions at different levels. There's 3 columns wide. So what I did was I made a script for this bottle, or for the potion. And I found out that if you use tool at the top of your script, it will allow your code to run inside of the editor. So if you make a change in the editor, you can do something in code that affects the rest of the node tree, which is really cool. So I exported this integer empty, low, medium, full, basically the different fill levels of the potion. I set it to 0 to begin with, and then when you set or get that value, fill level, I'm calling the fill potion function. So what I'm doing is I'm changing the fill level to equal the value. I'm calling reinit. Reinit will get the sprite right here, and it will set the frame of the sprite. So this sprite has all these different potions as frames. So you can see right here, vertical frames set to 5, horizontal frames set to 3, and currently we're on frame 0. If I change that, you can see the potions change. So what I'm going to do in the script is, if it's anything other than empty, right? So empty equals 0. If it's empty, I'm setting it to frame 0, empty bottle. But if it's anything else, I'm going to set its frame to the color times 3, which is the columns, plus the fill value. And this 2+ is for these 2 empty spots right here. So what that does, let me show you in the editor real quick. So here's my bottle. It's empty, right? Right here it's empty. Let's change it to low and watch what happens. Boom. Let me change the color real quick. So you can see it fills up to the low value. Medium, medium, full, full. What I can do is every time I place one of these, I can set its value in the level editor. So if I want to have invincibility for a real long time, I would do purple full. But if I want to only have it to get past one enemy, maybe I'll do purple low, something like that. That was kind of neat. That's something I haven't seen before. It's probably not groundbreaking or anything, but it was cool to me, and I thought I'd share it. And so I'll show you how that works in the level. So select the parent. I'm going to put everything on the level itself here. I'm going to link in the potion scene. Now, up here in the corner is my potion. Place it in level. And this guy will be a medium red. So, just like that, I have the potion. Let's run the game and we'll see it inside the game. I broke something. Wow, that's how that went, huh? Let's see. Script. Sprite. It has a sprite. Maybe I need to make it something more. Potion. Sprite. Huh, that's so weird. That's weird. Well, like I said, I'm learning. Go back to do something weird here. That got a new one. And the potion. Ah, of course. Let me check here. Here's the potion. Change the value to medium. Hello. Weird. Set frame and base null. Potion 2. Well, anyway, I'll figure that out offline. I don't want to spend the whole stream trying to debug this weird potion thing that I'm learning. So far, I have 2 different tile sets. So I have the platforms on the mid-ground, platforms and walls, things you can collide with on the mid-ground. And then I have all the visual background on this level. And then I have a parallaxing background as well, which while I'm building the game, I'm going to turn it off so it's a little bit easier to see what I'm doing. But anyways, let's go mid-ground here. I'll place this block there. It's that easy. I mean, it's really easy to use their tile system. I think it's super cool. Let's run this and we'll jump over there and we'll see those tiles. Hopefully I can get up on the step. And see, and they're collidable. That's what's so cool about it. Anyway, what I'm going to work on, since I can't really do the potion thing that I was planning on doing, I'll work on a skeleton AI. A skeleton is going to be your main nemesis as a scientist. It's going to come after you just because I have skeleton graphics available to me through the open game art. So let me start a new scene. And a skeleton is going to be made out of a kinematic body 2D. And we're going to call it Skell. It's going to have a sprite, of course, so you can see what it looks like. Great. I don't know if I have. Let's see. I don't think I have the skeletons separate from the player animations. I think I have them just, there it is. Open with. Why don't we use perhaps I want to use a sprite to open it. I'm having the hardest time working my own computer today. I can make games, but I can't use computers. There we go. All right. So there's the little skeleton that I'm going to make as our bad guy. And what I'm going to do is, first of all, I'm just going to copy him off. Oh, that is not the marquee tool. Copy just the skeleton. And I got one view. I want to see the actual pixels. There we go. Now we'll do a new one. Do width. Give them some room. We'll give them 10. Let's do 11 and height by 21. And then we'll turn off the grid. Show, take that off. Okay. So I'm gonna make a new layer. I'm gonna make this layer go below. And we're gonna give it a background color just so we can see the skeleton a little bit easier. Give it a dark green. Okay, so I'm gonna make a couple of animations for this guy. He's gonna have a little idle animation where he's just kind of standing still. And then he'll have a running animation. Don't believe I'm gonna make the skeleton jump. We will see about that. So first thing I'll do is make a new frame. And then in this frame, I'm gonna do something super easy, and it's kind of cheesy, but it works great for whenever you're doing an idle animation. Really, all you have to do is slunch the player over so it looks like they're breathing, just like that. I will export that. Export sprite sheet by rows, number of columns to horizontal. No, I want just layer 1. Frames, all frames, output file. Let's put this where it belongs. Oh man. Documents, my GitHub. Oh, where is this folder? Storage E. We will put it in images. We're going to call it scale idle. Scale idle. That's funny. Scale idle. Export it. Let's take a look and see what that looks like inside here. So we're going to go import. I'm not going to actually do it that way. I'm going to go sprite, go load, images, find my skeleton idle right there, then click open. There he is there. Looks kind of messed up. This is something that happens common when you're doing pixel art. This happens commonly inside of Godot. What you need to do is go here, go back to edit, and we're going to change these flags. Take the filter off, taking the bitmaps off, and we're going to change this up to 1. Why I got so aliasing was not part of my image. I'm looking inside another program right now, and the actual image isn't like that. So it's part of the importing that's causing that. Go back in Godot real quick. Delete. Cancel. Let's actually import the texture this time. We're going to get a 2D texture. We're going to find the images. Find this skeleton images. We're going to take it to the textures folder. We're going to say uncompressed. We don't want that. We don't want that. And we don't want that. And I believe that'll bring it in nicely. And then so what I'll do, I'll reset this and I'll say load this time. And I'll load it from the texture that I just made. Still looks wonky. Why is that the case? Textures, skeleton. Filter makes it look terrible. That's so weird. Like this, let's try it again. Didn't have that problem with my other images. Wonder if that was because they were square. Let's try that. Right. Canvas size. 21, 21. Well, since we're doing that, let's do yeah, we'll just do 21. Maybe it's the export settings. Exported image is actually good. You can see right here, this is the exported image. The way it's being brought into Godot. Ah, man, that's a bummer. Import texture 2D. Uncompressed. I'll do that. Better, but it still has that pixelation going on. Horizontal frames 2. Alright, well, I'm not going to worry about it too much. Let's save this scene. Bring the skeleton in and see how it looks. It might be too small. Where'd the skeleton scene go? Did it go in the textures folder? Did it go in the images folder? Scenes folder. Okay, try that again. Level 1, bring him in, skeleton. He's too tiny. Too tiny to be scary. Alright, so in our skeleton here, what we'll do is we'll bump up the size here. 2, 2. Boom. Save. Did not work. Alright. Having all kinds of problems with this today. Okay. I guess I'm gonna have to make the skeleton image twice as big. So sprite size, we'll make it 22. Oh, 21, so 42. Okay. Now let's see, even now, okay, that'll work. No, this will work. 5, export sprite, horizontal strip, layer 1 only, export, override, no. Texture, import. All right, let's see. Oh, there we go. Now that looks like a scary skeleton. But you notice it doesn't have the idle animation that we made earlier. To do that, our skeleton needs a animation player node. So animation player node. And then inside here, we have to make that animation. So we'll call this scale idle. What we'll do is in here, we will key on the sprites frame. Here, frame. Great. And as I did that, it automatically moved to the next frame. And so what that gives us is this cool ability to go, actually, to right here and go key. And then if we play this, turn on looping. If we play this, it will use idle animation. I thought. Okay, there we go. Now it should do it. I actually kind of like that slow speed compared to our player. Let's see what it looks like. Oh, not playing. Here's another thing you need to do. So when you find your animation that's going to be playing most of the time, you make that play automatically with this button right here, autoplay unload. Now, did that not work? Let's delete this skeleton, put a new one in, just to make sure you get the newest one. Go, play. Huh. Oh, I did not save the animation. Rookie. I'm having a hard day today. Scale idle. Now it should play. Yes, no, maybe so. Okay. Why do you hate me so much? This one should be frame 0. And this one should be frame 1. I gotta key this at the end. This is the weirdest thing. I can't get anything to work today. Process mode. We run just the scene. Run just the scene, you can see that the skeleton is animating. He's in my level, he doesn't animate. So weird. Sometimes you gotta shut down Godot and open it back up. Oh, that didn't work. Let's see. It didn't save with the animation player on it. How weird. Okay, let's try it again. Animation player. New animation. Skill idle. Okay, so what are we going to animate? We're going to animate the frame. T, create, create. Auto loop, autoplay, save it, animations, skill idle. Yes. What the hell? So weird. Save. Let's see if that works. Okay, gee minis. Alright, so there's my skeleton. He's got his little idol. That was painful. Sorry about that. Alright, the next thing we gotta do is we have to make a run sequence for our skeleton. So we'll come back to this one. I'll get rid of this green in this layer and fill it out all the way green. Okay. We are going to get rid of the second position, and we're going to take this and we're going to paste it in here. What we're going to do is we're going to edit the position of his arms and his legs to make it look like he's running. To do that, I will erase his arms. Ah. Plus. And his legs. We'll get rid of both. And let's see. Okay, so I turned on onion skin so I can see where his arms and legs were last time. Of course, we're going to pick up the white color. Our brush is size 2, and we're going to actually use a line for everything. So when you're running, let's see. Let's look at a run animation. I have to do this every time. So actually, let's look at the run animation that I have for my scientist. So to me, it looks like his arm and his leg on the same side are going in the same forward direction and the backward direction. Here, it looks different. All right, we'll just play and we'll figure it out as we go. Like I've been doing this whole time unsuccessfully. Ah, that's not the right color. So he's gonna have one arm going this way, while this leg goes this way. This arm goes this way, while this leg. That looks so funny. Frame. Erase. Line tool. Okay, so this. Going forward. This one's going back. This arm is this. That is definitely wrong. Oh man. So I'm gonna go with my first instinct, which was to put same leg and same arm Oh yeah. Wow, that's terrible. That is incredibly terrible. Okay. Better yet, let's pull up a run animation, run cycle. I use this one often. Okay. So I think the problem is I'm starting with out in this straight position, which no one would start off running like this. So let's get rid of this first position. And what we'll do is we'll start at the extreme right leg contact. That's going to be like this. And this leg is going to be back here. The right arm will be going forward. Or I'm sorry, that would be the left arm. And then the right arm is going back. Next up, complete these arms. Okay. So next will be the firmly planted. Where this leg is like almost completely planted. This arm will be almost straight down. And this one will be ever so slightly forward. And this leg is just slightly back. Okay, now let's erase that. There's probably an easier way to do this. I don't know how, if there is. Okay, now we're gonna have the push off. This leg is gonna be like this. This one will be like up in the air a little bit. This arm is gonna be coming across the body. And this arm will be going like that. It is kind of goofy, but maybe that's kind of what I want. Let's see. What I can do is I can add in the middle here, just like the idol, I can do a little cheesy trick and give him a little bounce to his step. There you go. I'll just run with that for now. So export spreadsheet horizontal strip layer 1 only, and then this will be scale run. Export that goofiness. Import texture. Texture. No map maps, no filters. Texture. Choose. Okay, so in the animation player, we're going to make a new animation. Call it scale run. let's actually delete the scale run. I like to get the capitalization the same. Okay, and what I'm going to do is in scale run, we are going to key on the texture. We're going to change the texture. Oops. Go back. We're going to load up the scale run texture. And that had 3 horizontal frames. So let's key that. That's the texture right here. So here we are going to key the. So let's go here, down to 0. That's strange. Scale. Okay, now I have the 3 frames. All right, so I'm going to key the frame, which will take it to 0, I believe. Create. It did not. All right, so these 3 I'm going to drag out. Let's see what it looks like. So on frame 0, we're on frame 0, 1. Zoom. I think I can. There you go. Try that. Alright, so that looks alright. We'll save that. Okay. So our skeleton now has two different animations. And why is that one playing? I know why. So in this idle animation, we'll stop it from playing, go back to 0. We need to key on the actual load and we key on this and key on this. Alright. So our skeleton now needs a collision shape so he can move around in the environment. So what we're going to do is we'll add a node. We're going to add a already a kinematic body. We'll add a collision shape 2D to him. Sorry. We'll make a capsule shape. We'll zoom in. We'll place that on the character. And that looks pretty good. So what I'm going to do is I want to make him move in one direction. And then when he reaches the edge of a ledge, he's going to turn around and go back the other direction. So to do that, I'm going to add a script. I'm going to call it skill. We need to put it in a different folder. It doesn't go in the scenes, it goes in the scripts. Go ahead and create. Get rid of all this. And we're going to say set process true. We're actually going to say set fixed process true because it's going to have physics. Set fixed process delta. This will have a velocity, so already well equals, it's going to be a vector 2. That's going to be 0, 0 for to initialize. We'll actually set it to, let's see, we'll make another one. Another bar block speed equals, I don't know, 10. Bar go right equals true. I'm going to say if go right velocity x equals walk speed times delta move velocity. So what this should do is the skeleton should just walk right forever and ever. He's going to run into this, so what I'm going to do is I'm going to move him over here and start the game. Let's see what happens. So he's walking right. Oh, he's pushing into me. How cool is that? So you already have interactions. I'll be able to stomp on his head. Bam! Blah, die, skeleton. Blah. Alright, but anyway, he's walking right, but you can see that he runs into something. So now we're going to use ray casting. Ray casting is super cool. So I need to put a ray node on this guy. We're going to put a raycast 2D on him. And you'll see that right now it's kind of pointing down and not really looking forward. So these rays are going to be sort of like his eyeballs, see what he can see, or if he's touching something, it's going to trigger him to turn around. That's exactly what this one's going to do. So I'm going to say cast to 5x and 0y, so it's straight out. But I don't want it way up here. I actually want it down by his feet. And we'll call this wall ray, or ray wall, because this is going to be looking for walls. If he sees a wall, he's going to turn around, go the other way. So back into my script, I'm going to get that a pointer to that raycaster, so I can check if it's hitting a wall. I'm going to say on ready var ray wall equals get node ray wall. Now in here, this is where I'm going to, if it hits the wall, I'm going to turn around. So I'm going to say if ray wall, let's see, ray wall dot is colliding. So if the ray wall hits something, what am I going to do? I'm going to say go right does not equal, or I'll say times equal, no, I'll say this, equals not go right. What this will do is just flip the go right back and forth, back and forth, back and forth. Then I'm going to say if else, no, I'll say if go right equals false, velocity dot x equals negative walk speed times delta. And if all goes right, which nothing has today at all for me, but if all goes right, you should walk forward, bump into something, turn around, walk the other way, bump into something, turn around, so on and so on. Let's see if that works. Gonna bump into me. Nope, didn't work. Let's see if it works on this. Oh, ha. Know exactly why this isn't working. This has bitten me a few times. It's really pissed me off. Inside here, when you have your ray, you have to say enabled on. That damn thing right there is costing me so much headache. There is one other thing we need to do in the side of our script. So on ready, we need to say ray, oops, ray, come on, ray wall. We're going to add an exception, and we're going to say self, because we don't care if the ray cast is hitting ourselves. We just want to care. We only care if it's hitting something else. Now this should work. Hit me, turn around, goes the other direction. But what it didn't do is it didn't turn the actual player around. It just changed its movement position. So what I'll do is I'll turn on visual collision shape so you can see it happen. See his ray there? When he hits me, his ray is still pointing this direction, to the right. That's not gonna trigger when he hits the wall on his left. So what I need to do is I have to flip him. And the easiest way, I don't know if there's another way to do this or not. The easiest way that I've done this is to, since I'm working on this top level kinematic controller, is to change the X scale. I just changed the X scale to turn it to the left. I'll show you how I do that. So if go right, I'm going to say set scale vector 2 1 1 go. And I'm going to cover this line of code, put it here. So I'm going to flip the X scale. Now watch what happens. It hits me, boom, turns around, goes the other direction. It's sort of cheating, but hey, that's how a lot of games are built. They kind of cheat like that. What I did notice is he doesn't have any gravity going on. Let's move him up to make that apparent. So yeah, no gravity, not gonna happen. So what we need to do is give him, see how my player has a little raycast pointing down? Need to give him a raycast pointing down and say if that one's not colliding, then I'm falling, basically. So we'll go back to our skeleton. We'll add a new node, do another raycast 2D. This time it is pointing in the right direction, but it's going way too far. So what I'm going to do, first things first, I'm going to turn this thing raycast on. Then I'll change this down to, I don't know, like 5 pixels, maybe 3 pixels, fine. And then I'm going to call this ray floor, because that ray is looking for the floor the whole time. Go in the script, we're going to do the same thing right here. Say on ready bar ray floor equals get node ray floor. Come on, I can't type today. All right, so now in the fixed process here, I'm going to say add gravity to myself. So first thing I'll do is say velocity dot y plus equals gravity. We'll just call it graph. I'm going to define that up here. Var graph equals 300. I don't know, 300 is fine. Because we're going to times this against delta. What that does is basically, if this gets the time that has passed since the last time this function has run, and then it scales your constants for your physics, it scales them linearly across time. So say there's like a lag for a second and your fixed process doesn't run perfectly on time. It will move the right amount based on the time that has passed, not on how many cycles it's gone through. That was a terrible explanation, but that's all I got right now. So I'm going to do if ray floor is colliding, not connected, colliding. Let's say velocity dot y equals 0. We forgot one other thing. We don't want to collide with ourselves. Ray floor add exception. Ah, I spelled it wrong. That's why all my code hints weren't working. So now we should see the skeleton fall when the level starts. Keep an eye on him because he might fall really fast. Here we go. Oh wow, he's already on the ground. That was way too fast. So what happened? We'll try that. Wow, he falls so fast. Ooh, okay, that's a little bit better. Not fast enough now. We'll try 7. Okay. So now he'll walk around. His walk speed's way slow. Let's make that a little bit faster. He'll walk around, and it looks like it's working. Looks like, oh cool. Now I got some AI. All I gotta do is when he hits me, subtract my health, or if I land on his head, kill him. There's a problem with this AI. This dude is not so smart. This skeleton is really dumb. And let me show you what I'm talking about. We'll go in here. Actually, we'll make a whole new scene just to test. We'll make a test scene just for the skeleton. We'll make a new scene. We'll just put a node as the root, and we'll call it test scale smarts. I don't know. No, we won't call it smarts. We'll call it AI. Test skeleton AI. This is going to be like a sandbox room just to see how dumb this guy really is. So first thing I'm going to do is I will add a tile map so I can build some sort of platforms for him to stand on and such. We're going to pick one of my tile sets that I already have built up. We'll use this one. And we're going to change this size down to 8 by 8. Just gives us a really easy snapping to use. Put this out. I'll use these tiles here. Oops. Give them a platform to walk on. That should be good for now. We're going to add in a skeleton. So he's in our scenes. Skeleton. Oh man. Okay. Skeleton is not a child of the tile map, it's a child of the test room. So, if we run this thing, well, it's going to ask me to save it first. I'm going to save it in the scenes. It's called test skeleton AI. If we run this thing, watch what happens. He falls, he's walking, he's walking, he's walking, gets to the edge, kind of stops, kind of freaks out a little bit. Eventually, he's going to fall off. He didn't fall off that time because he's not going very fast. But let's say if he was running, if he's a running skeleton, phew, falls right off. Okay. That is not what we want. So, we need to make the skeleton look forward and down to see if he can walk there. So, we'll go back to our skeleton. We'll go back to the 2D view of him so we can see. We're going to add something to him. We're going to add another raycast. And this one is going to look forward and down. So, here we're going to say, let's look 10 forward, 10 down. See, now you got this cool little forward motion. See, what I'm going to try to do is put it on the same level as his feet. One of the cool things you can do is you can use the windows themselves to kind of show you where the feet are. I'm going to say a little like that. Okay, we'll call this array. What can we call it? Array forward. Of course, brown cow says it'd be epic if that was a brown cow, but it's just a skeleton. Array brown cow. Okay, so using this raycast, he's going to be looking forward to see if this ever collides. We'll go back to the script yet again and add another one of these. Already array forward is get node gotta add the exception. Don't want to collide with ourselves. Array forward. And, but you thought I was going to forget, but I'm not ever going to forget that again. Enable that raycast. So, all I have to do is, if right here, inside here, if ray wall is colliding, so if I hit the wall, I turn around. What else would make me turn around? Well, if the ray forward was not colliding, I would want to turn around. So all I need to do is right here, go and not ray forward is colliding. I believe that'll work. So let's go back to our skeleton test scene. Let's get our little skeleton on the ground, a little close to the ground. Let's run this and see if it works. Didn't work. Okay, so I was afraid of that. Sometimes this doesn't work for me very well. So I'm gonna go with the old school pound like that. Let's see if that works. Ah, no, it did not. Maybe it's pure logic error. Or that's pretty funny. Oh geez. That's pretty funny. He's just freaking out. That's because his raycast here is not fighting ever. There we go. Okay, so that looks cool. Works good in the game still. Let's test it in the tester. Ah, wrong button. Let's see. Oh, and he turns around when he gets the edge. That's perfect. Perfect. So now, my guy will turn around when he gets near an edge. Won't fall off. Won't be stupid. I think that's going to be it for today. Inside my level, he's going to act a little funny, but let's put him over here. Let's run this level and see. Oh, let me turn off the collision so it'll look a little cooler. Run this thing. Jump. Oh, you know what? While I'm here, let's turn on the background. Just to show how cool this game is getting there. Oh, look at my skeleton. Ah! Ah! Jump on his head. So I think that's it for now. Thanks for joining my stream, and I will keep you updated on my progress. Probably be working on this every Wednesday for the next few Wednesdays until the jam is over. Hoping to have a pretty cool entry by the end of all this and have a lot more knowledge of how Godot works. You saw me struggle in the beginning, but I'm learning. So anyway, that's all that matters. Take it easy. Thanks for joining.